6.2, number 7, use the indicated substitution to evaluate the integral. So we're using u substitution. They even tell us what u is. So I would have, if I didn't know that, we really have a couple options. This, what's in parentheses, and what this. If you have a 1 or a constant plus or minus something, that's usually a sign that that should be your u, because when you find the derivative, that will disappear, and you could likely be able to divide off whatever else is in the integral. So this in parentheses squared, that should be your u. They tell us that, but that's kind of the thought process. With the derivative of cosine or negative cosine is going to be either positive or negative sign. So we should be able to cross this out because we're dividing by the derivative of whatever our u is. All right, so moving forward, u is 1 minus cosine of t over 2. So then du, if you wanted to make these x's, because we talked about solving for dx, we now have t's. So that would avoid some confusion if you just made them all x's. Nothing wrong with that. So du dt equals the derivative of negative cosine is sine. So it's the sine of t over 2 times the derivative of the inside, whatever we're taking the cosine of. Well, that derivative is just 1/2, because that's 1/2 t. So it's 1/2 sine of t over 2. So we'll solve for dt, move it there, move this over there, so you have du over 1/2 sine of t over 2 equals dt. So now we're ready to write our integral in terms of u. This is our u. And our dt is du over 1/2 sine of t over 2. Well, as we expected, the sine of t over 2's do divide off. Dividing by 1/2 is the same as multiplying by 2. So we have 2 integral of u squared du. Antiderivative of u squared is 1/3 u cubed. Still have our 2 there. So it's 2/3 u cubed plus c.